Hi everyone, welcome to this YouTube channel. Today we're going to look at the solution to NECO Chemistry July 2023, the theory paper. We're looking at the solution, the final solution, giving accurate answers to the questions. Please, if you are not subscribed to the channel, do well and subscribe so that you can be seeing our videos as we post our videos to the channel. How do you subscribe? Just look at the name of the channel, Best Science Brain. Under it, you see a small bell. Tap on the bell or touch the bell and get subscribed. That bell is bearing subscription. So once you touch on the bell or you tap on it, you change it to subscribe. You tap on it once and get subscribed. So that whenever we post our video, you can see our video. Subscription does not remove your data. Rather, it makes you to be one of the first people that will see our video when we post it. So get subscribed so they don't have to start searching us through YouTube. So that whenever we post our video, you'll be among the first people that will see our video. We'll now go to the question. Question says, answer any 4 questions from this paper. Question 1A says, list 3 uses of sulfur. We'll go to the solution. Sulfur is used for industrial manufacture of the dose of acetic acid in the contact process. Sulfur is used to manufacture matches, gunpowder, and dyes. Sulfur is used in vulcanization of rubber. Say any of these 3 scores. Go to 1AII, which says, mention 2 physical properties of hydrogen sulfide. A, the first one, solution is a colorless poisonous gas with rotten egg smell. Number 2, it is denser than air, in bracket about 1.18 times denser than air. So now go to 1A-triple-I. So 1AIII says, state one difference between soaps and detergents. Solution, soaps form insoluble calcium salts, otherwise called scum in bracket, with hard water, while detergents do not form scum or react with hard water. Hence, detergents produce lather with soap. Somebody can say that soap does not lather with hard water, while detergent lather easily with hard water. That is also correct. So 1AIV says, give one use of detergent. Solution, detergents are cleansing agents used in laundry. That could be one use, or you can say detergents are used to control oil spillage on water bodies. 1BI says, what are the number of neutrons in the following elements? We have 1BI, capital I, S, mass number 23, atomic number 11, II, Y, mass number 39, atomic number 90. We're asked to find number of neutrons. And to find number of neutrons in an atom should be mass number minus atomic number. That is 23 minus 11 and 39 minus 19. So going to the solution, for I, the answer is 12 neutrons. 23 minus 11 there is 12. For II, the answer is 20 neutrons. 39 minus 19 is 20 neutrons. 1BII says, consider the reactions. 4 moles of sodium plus 1 molecule of oxygen giving us 2 moles of sodium oxide. We asked, what is the mass of oxygen needed to burn 9.2 grams of sodium? And in bracket, we have the atomic mass of sodium and oxygen given to us as 23 and oxygen and 16 respectively. Going to the solution, have the equation written again. Then we'll have to find the molecular mass of oxygen being 16 times 2 as 32. We'll have to find the mass of 4 moles of sodium, which is 4 times 23. 23 is the atomic mass of sodium. That gives us 92.0 grams. So for the balanced equation, we have 4 moles of sodium is equivalent to 1 mole of oxygen. 4 moles of sodium have been calculated to be 92 grams. So 92 grams of sodium is equivalent to 32 grams of oxygen, which is 1 molecule of oxygen. Then therefore 9.2 grams of sodium will now give us 9.2 times 32 over 90 to give us 3.20 grams of oxygen to 3 signifying figures. Going to number IB, 1B, triple I. Calculate the number of moles of calcium chloride that can be obtained from 50 grams of limestone in the presence of excess hydrogen chloride. We have the atomic masses of calcium, carbon, oxygen, hydrogen, and chlorine given to us in the bracket. We now go to the solution. We have the equation there between calcium carbonate and HCl. So 1 mole of calcium carbonate reacted with 2 moles of HCl to give us 1 mole of calcium chloride, 1 mole of water, and 1 mole of CO2. Mass of limestone is 50 grams. Molar mass of calcium carbonate. Mind you that calcium carbonate stands as limestone. Giving us 40 plus 12 plus 16 times 3, giving us 100 grams per mole. Number of moles of calcium carbonate is given as mass over molecular, which is 50 all over 100, giving us 0.50 mole of calcium carbonate or limestone participating in the reaction. We now go to the stoichiometric reactions. 1 mole of the carbonate produce 1 mole of calcium chloride. So we have it there. 1 mole of the carbonate gave us 1 mole of calcium chloride. Therefore, 0.5 mole of the carbonate, as we have calculated, will produce also 0.50 mole of calcium chloride as our answer to the question. 1CI says, mention 2 types of colloidal solutions. The answers include source, aerosols, emulsions. Any 2 will score. 1CII says, state the law of definite proportion. Solution. The law of definite proportion states that all pure samples of a chemical compound contain similar elements combined in the same proportion by mass. 1C triple I says, calculate the molecular mass of the following: I, sodium trioxide 5, II, copper 2, tetrasulfate 6 pentahydrate. Going to the solutions. The first one, we'll have to write the formula of the compound, sodium trioxide 5, as correct formula is NaNO3. Then substituting with the atomic masses of sodium is 23, nitrogen is 14, oxygen is 16 times 3. And adding up everything, we're going to have 85.0. Relative molecular mass has no unit, so the answer is 85.0 to 3SF. Then the other second question is copper 2, tetrasulfate 6 pentahydrate. Formula is CuSO4.5 water. Using copper as is 3.5, with the accurate rated elements of copper is 3.5, not 64. So 432, oxygen 16 times 4 plus 5 into 2 times 1 for hydrogen, then plus 16 for oxygen. Solving everything, we're going to have 249.5, 249.5 at the relative molecular mass of copper sulfate pentahydrate. Now we are done with number 1. We're going to number 2. Number 2 says, calculate the mass of silver deposited, 2AI. Calculate the mass of silver deposited when a current of 4.6 ampere is passed through a solution of silver salt for 90 minutes. And we are given the atomic mass of silver 108, 1 Faraday as 96500 coulombs. Going to the equation, first of all, we have to write the reaction occurred at the cathode, which is reduction of silver ion to give us silver. So you have the silver 1 ion plus an electron giving us silver solid. Current that was passed is 4.6 ampere. Time is 90 minutes to convert seconds, which is 90 times 60, giving us 5,400 seconds. Find the quantity. Quantity is current times time, which is going to be 4.6 times 5, 4, giving us 24,840 coulombs of electricity. Then we'll go to the equation. We'll now see that 1 mole of electron is equivalent to 1 mole of silver. So 1 mole of electron, which is equivalent to 1 mole of electron, silver. And we know that 1 mole of electron is equivalent to center as 1 Faraday. It's equivalent to 1 mole of silver. Then converting to coulombs, we now have 96,500 coulombs, giving us 108 grams of silver. Therefore, 24,840, which the quantity was passed through the cell, will now give us 24,840 times 108 all over 96500 by proportion. We now have 27.8 grams of silver deposited to three significant figures. Number 2 says, there is number 2AII says, give two factors that affect the discharge of ions during electrolysis. Solution: position of ions in the electrochemical series or in the activity series. 2. Conserve ions in the electrolyte. 3. Nature of electrodes. Any of the two will score correctly. 2A says, identify the oxidizing reagents in the reaction below. We have the manganese 7 ion plus 5 moles of iron 2 ion plus 8 moles of hydrogen ion, giving us 1 mole of manganese 2 ion plus 5 moles of iron 3 ion plus 4 moles of water. We'll now go to the solution. So going to the solution, the oxidizing agent is MnO4 because the MnO4 ion there, the oxidation of manganese here is +7. And then, so you can see from the equation that manganese has its oxidation state. He has +7. Then going to the product side, it is +2. So this is the oxidation agent because the oxidation state of manganese here has decreased from left from +7 to +2. Because the oxidation agent must be the substance that will be reduced in a redox reaction. While iron 2 is the reducing agent because it's the one that been oxidized from +2 is going to +3, being the oxidized substance. So that means that the oxidation agent there is the 3 manganese 7 ion. The agent there is the iron 2 ion for question number 2A III. Question 2A says, write the half cell equation for in 2A III above. So you have the oxidation half cell. To write the oxidation half cell, we use the reducing agent, iron 2 being oxidized to iron 3. The oxidation half cell will have use the oxidation agent to write the oxidation half cell, 1 mole of manganese 7 ion plus 8 moles of hydrogen ion plus 5 moles of electron, giving us 1 mole of manganese 2 ion plus 4 moles of water. This one is the reduction half cell equation. 2BI says, draw and label the apparatus that can be used for the separation of two immiscible liquids. Draw and label the apparatus that can be used for the separation of two immiscible liquids. The solution to separate two immiscible liquids will use the separating funnel. You can see the diagram there, labeled. We see the separating funnel labeled there. You see, you can use two liquids. You can use petrol and water. Petrol being less dense than water is up, while water being denser is below the petrol. You can see the demarcation line separating petrol and water. You can see the tap, very important on the separating funnel. When the tap is open, you see water dripping down into a beaker. So water is flowing into a beaker, and then we have the rotor stand and the clamp holding the separating funnel. And then we have the diagram fully labeled. Now go to question number 2BIII. 2BII says, mention 2BII, three properties of gases. So solution, gases do not have fixed shape. Or you can say gases can retain the shape of their containers. They don't have fixed shape. 2, gases do not have fixed or definite volume. 3, gases have low melting and boiling points. And then 4, the intermolecular force of attraction and repulsion between gas molecules is very negligible or very weak. So any of these 3 is okay. Then going number 2BII says, state Faraday's second law of electrolysis. Solution, Faraday's second law of electrolysis states that when the same quantity of electricity is passed through 2 or more electrolytic cells connected to the same battery in series, then the number of moles of the deposit elements vary inversely to the charges on their respective ions. When the same quantity of electricity is passed through two or more electrolytic cells connected to the same battery in series, then the number of moles of the deposit elements vary inversely to the charges on their respective ions. So this is for the first law of electrolysis. Question 2BIV says, name two amorphous forms of carbon. Solution: the amorphous forms of carbon include charcoal, coke, gas carbon, lamp black. Any of the two is correct. Then 2BV says, arrange the following metals in order of decreasing chemical reactivity. We have magnesium, aluminium, calcium, sodium. Solution: decreasing chemical reactivity means from the most reactive to the least reactive. The answer there will have the arrangement. Sodium is the most reactive, followed by calcium, followed by magnesium, and the least reactive there is aluminium. We'll move on to number 3. Number 3 question says, clarify the following into primary, secondary, and tertiary canons. Number 1, butan 2-or, II 2-methylpropanol, III 2-methylpropan-2-or. Solution: butan 2-or is secondary alkanol because it has two alkyl groups bonded to the carbon atom of the hydroxyl functional group. II 2-methylpropanol is a primary alkanol because it has only one alkyl group bonded to the carbon bearing the hydroxyl group. Then III 2-methylpropan-2-or is tertiary alkanol because it has three alkyl groups bonded directly to the carbon of the hydroxyl group. So I is secondary, II primary, III tertiary. Going to number 3A, II says, state two methods by which ethanol can be produced or prepared commercially. Two methods by which ethanol can be prepared commercially. We'll go to the solution. The answers is 1, fermentation of starchy substances or molasses. So fermentation is the key word. Fermentation process, either you ferment starchy substances or molasses. Molasses signifies sugar. Then you can also get ethanol commercial by hydration of ethene. Hydration of ethene, not ethane, ethene, in the presence of tetrodophosphate 5 acid catalyst. Number 3A, triple I. If hydrogen diffuses 6 times as fast as a gas Z at the same temperature and pressure, calculate the relative molecular mass of Z, given that the relative molecular mass of hydrogen is 2. If hydrogen diffuses 6 times as fast as a gas Z at the same temperature and pressure, calculate the relative molecular mass of Z. And we are given that the relative molecular mass of hydrogen gas is 2. So let's go to the solution to the problem. So since hydrogen diffuses 6 times as Z, that means the ratio of the rate of diffusion of hydrogen to gas Z is 6:1, as you can see there. So the molecular mass of hydrogen, that N represents molecular mass of hydrogen is 2. The molecular mass of Z is M. That's what we're looking for. We now apply the Fermat-Graham law of diffusion where rate is inversely proportional to molecular mass. So now I have R hydrogen all over R Z equal to square root of mz all over root of m hydrogen. So we can say that the rate of each gas is inversely proportional to the square root of its molecular mass. The rate of hydrogen gas is up there, while the molecular mass of hydrogen gas is down there. The rate of Z is up, while the molecular mass is down, while the molecular mass is up there. So placing everything very well and then substituting, the rate of hydrogen gas is 6 from that ratio there. The rate of Z is 1. The molecular mass of Z is M, unknown, while the molecular mass of hydrogen is 2. Then we have that the substitution done there. Then we square both sides. When you square both sides, we now have 6 over 1 squared equal to root of m over 2 squared. Then have 36 equal to m over 2. Then multiply. M now becomes 36 times 2, giving us 72.0. So the molecular mass of Z is 72 from the calculation. 3bi says write the electronic configuration of oxygen using the SPDF notation. We'll have it over there. The solution, oxygen whose atom number is 8. 1s2, 2s2, 2p4. That's the right answer to that question. 3bii says list 3 physical properties of oxygen. List 3 physical properties of oxygen. Then go to the solution. So the answers A, oxygen gas is slightly denser than air, about 1.1 times denser than air. Number 2, oxygen boils at minus 183 degrees Celsius and solidifies at minus 218.79 degrees Celsius. You can as well say that oxygen is a colorless, odorless, and tasteless gas. 3bi says give 2 rules of naming alkenes. Give 2 rules of naming alkenes. Solution. The first, we say take the longest continuous chain as the parent, or in bracket root chain, and end the name with the suffix ene. I come again. Take the longest continuous chain as the parent, or in bracket root chain, and end the name with the suffix ene. The number 2, where a substituent exists in the parent chain, then number the parent chain from the end that gives the least possible number to the carbon atoms of the double bond. Where a substituent exists in the parent chain, then number the parent chain from the end that gives the least possible number to the carbon atoms of the double bond. 3biv says write an equation to show the oxidation reaction of 18. Write an equation to show the oxidation reaction of 18. So we can see the solution there. That's 18, 3 molecules of 18, reacting with 2 molecules of potassium manganese 7, cold alkaline potassium manganese 7, in the presence of 4 molecules of water, to give us 3 molecules of ethane 1,2-diol, a dihydroalkanol, plus 2 molecules of manganese 4 oxide, and 2 molecules of potassium hydroxide. So this is the reaction of 18 in the presence of an alkaline potassium manganate and water, to give us 3 molecules of ethane 1,2-diol, 2 molecules of manganese 4 oxide, and 2 moles of potassium hydroxide. 3c say define an endothermic reaction. Solution. This is a reaction in which heat energy is absorbed from the surroundings. A reaction in which heat energy is absorbed from the surroundings. 3cii says write the equation for the laboratory preparation of hydrogen by the action of dilute tetrasulfuric acid on zinc. Write an equation for the laboratory preparation of hydrogen by the action of dilute tetrasulfuric acid on zinc. You can see the solution there. Zinc, 1 mole of zinc plus 1 mole of H2SO4, giving us 1 mole of zinc sulfate in aqueous state plus 1 mole of hydrogen gas. 3C III says state the type of reaction that is involved in CII above. So we are the kind of reaction that is involved in between zinc and H2SO4. The answer to the question is displacement reaction, because zinc, being more electropositive than hydrogen, were able to displace hydrogen from H2SO4, as you can see there. 3CIV, state the use of hydrogen gas. First, production of ammonia gas in the Haber process, when it is reacted with nitrogen in the ratio of 3:1 by volume. So hydrogen gas is used to manufacture ammonia in the Haber process. Number 2, hydrogenation of vegetable oil in the presence of nickel catalyst to produce margarine. So hydrogen gas is used to make margarine when it is passed through vegetable oil. So hydrogenation of vegetable oil in the presence of nickel catalyst to produce margarine. Number 3, it is used in the production of oxyhydrogen flame used in welding and cutting metal scraps. So these are the use of hydrogen. Any of the 3 is okay. We'll go to number 4. Number 4AI. What is a supersaturated solution? Going to the solution. Supersaturated solution is a solution which contains more solute than it can dissolve at a given temperature in the presence of undissolved solute particles. A solution which contains more solute than it can dissolve at a given temperature in the presence of undissolved solute particles. Question 4AII. 25 cm cube of distilled water at 30 degrees Celsius dissolved 15 grams of lead 2 triosonitrate 5. Calculate the solubility of the solute in mole per dn cube. We're given the atomic mass of lead as 207, nitrogen as 14, and oxygen as 16. We'll now go to the calculation. So here we listed what we need from the equation: volume of this water or volume of solution is 25 cm cube, mass of salt dissolved is 15 gram, molecular mass of the salt, lead nitrate, is calculated there, 207 plus, bracket opens, 14 plus, 16 by 3, and that bracket, then bracket 2, giving us 331 gram per mole. We apply that formula, mass over molecular mass equal to CV over 1000, where the C stands for concentration or solubility. Making C the subject of the formula, will have mass times 1000 all over volume times molecular mass. Then making correct substitution, mass is 15 times 1000, volume is 25, and molecular mass is 331. Solving out, we have solubility or concentration as 1.81 mole per dn cube to 3 significant figures. 4AIII says, give 3 examples of complex ions. We'll go to the solution. The examples are here. You can have the ion, hydrated ion, which is, the name is hexaquoferritre ion, hexaquoferritre ion. Then the other one, Fe bracket Cm bracket C, is then 4 minus raised up. That one is called hexacyanoferrate 2 ion. Ferrate 2 ion. Ferrate from the word ferrium, ion. Then the other one, nickel in bracket ammonia, 6 molecules, and then 2 charges plus 2. The one is named hexaamine nickelate 2 ion. Hexaamine nickelate 2 ion. So these are 3 examples of complex ions. We'll now move to 4BI. Says state 3 evidence to show that air is a mixture of gases. 3 evidences to show that air is a mixture of gases. Going to the solution. 1, air cannot be presented by its chemical formula, because a mixture cannot have a formula. 2, the constituent of air retain their individual chemical and physical properties. The concept of air retain their individual chemical and physical properties. Number 3, the composition of air varies from place to place. So these reasons suggest that air is a mixture. 4BII says state 2 constituents of air. Solution: nitrogen is there having 8%, oxygen is there having 21%. You can see mention carbon dioxide having 0.03%, 0.03%. You can see mention noble gases or rare gases having less than 1%. 4BIII says calculate number of hydrogen ions produced by 0.1 mole of H2SO4 in water, and they will have the Avogadro's constant at 6.0 times power 23 per mole. We'll now go to the solution. So first of all, we'll write the ionization equation of the acid H2SO4 plus giving us 2 moles of hydrogen ion and then 1 mole of SO4 ion. Then for the balance equation, we can say 1 mole of the acid produce 2 moles of the ion. 0.1 mole of the acid that's given the equation will now produce 0.1 times to give us 0.2 mole of hydrogen ion. The number of ions you give by the formula, number of moles times Avogadro's constant. That will now give us 0.2 times 6.0 times power 23. That will give us 1.20 times power 23 ions present. 4BIV says mention 2 types of chemical combination. Chemical combination, also known as chemical bonding. The examples include heterovalency or heterovalent bonding, covalency or covalent bonding. You see how some other examples. 4BV says state the constituents and one use of the following alloys. The first one brass, second one bronze. Now going to the solution, brass, the constituents are copper and zinc. Then what is brass used for? Brass is used for producing musical instruments and parts of watches and clocks. Then bronze, the constituents include copper and tin. What bronze used for? Bronze used in the production of coins and medals or even trophy. Going to number 5. 5AI says, what is a base? A base could be defined in different ways. First, a base is a substance which neutralizes an acid to produce salt and water only. Only is the key word there. Or a base is a proton acceptor in an aqueous solution. Or a base is electron pair donor in a chemical reaction. So any of the definition, any one of them scores correctly. 5AII says give 2 examples of basic oxides. Solution examples include sodium oxide, calcium oxide, magnesium oxide, potassium oxide, copper 2 oxides. So metallic oxides are actually basic oxides except aluminium, zinc, lead, tin, and beryllium. These ones are not considered as basic oxides, but most metallic oxides are basic, apart from the ones I'm giving here. 5AIII says give 2 uses of iodine. 1. Iodine is used in pharmaceutical and disinfectants. So used for producing what's called tincture that is mainly used as disinfectant for wounds. So iodine and mixed with ethanol is called tincture that is normally used for cleaning wound. So number 2, used to confirm the presence of starch in the laboratory. Then 5BIV says mention 1 difference between an aliphatic and aromatic hydrocarbon. 1 difference between an aliphatic and aromatic hydrocarbon. Going to the solution, aliphatic hydrocarbons, the symbol there has C stands for hydrocarbons. Aliphatic hydrocarbons contain carbon and hydrogen atoms arranged in straight or branch chains, while aromatic hydrocarbons contain carbon and hydrogen atoms arranged in rings with delocalized pi electrons. I repeat, aliphatic hydrocarbons contain carbon and hydrogen atoms arranged in straight or branch chains, while aromatic hydrocarbons contain carbon and hydrogen atoms arranged in rings with delocalized pi electrons. Go to 5AV. An element S has relative atomic mass of 10.8. Calculate the vapor density of its chloride with the formula SCl3. So we'll now go to the solution. We'll first of all find the molecular mass of SCl3. Adding up the atomic masses, S is already given to us as 10.8 in the equation. Chlorine is at 5.5 multiplied by 3. Adding everything together, we have 117.3. That's the relative molecular mass of SCl3. We know in chemistry that vapor density is given by relative molecular mass over 2. So we divide the relative molecular mass by 2. We now have our vapor density. We now divide 117.3 by 2. We now have 58.65 as our vapor density. 5BI says mention 3 factors that affect the rate of a chemical reaction. Mention 3 factors that affect the rate of a chemical reaction. Solution, temperature, nature of reactants, surface area. Some can still mention concentration, stroke pressure. Some can still mention light. Some can still mention the presence of a catalyst. 5BII says state the law of conservation of energy. Solution, energy is neither destroyed nor created, but can be changed or converted from one form to the other or to another. This is the law of conservation of energy. Energy is neither destroyed nor created, but can be changed from one form to another. 5BIII says give 2 examples of chemical changes. Give 2 examples of chemical changes. Solution, fermentation of starch, corrosion of metals, or you can say rusting of iron, combustion of wood, acid hydrolysis of proteins or starch. So any of these can represent a chemical change. 5C says compounds A and B react to form activated complex AB, producing compounds C and D, given that the enthalpy change is positive. Draw the energy profile diagram. Compound A and B react to form activated complex AB, producing compounds C and D. Given that the enthalpy change is positive, draw the energy profile diagram. We'll go to the solution. So you can see the diagram, the energy profile diagram for that question. The vertical axis is labeled energy in joules. Horizontal axis is labeled reaction pathway. All these are very important. You have to do that. And then we are reactants here. A and B are the reactants. C and D are the products. HP, that the heat content or the enthalpy of product. HR with the enthalpy of reactants. The straight line drawn from the reactant base to the peak of the hill is called activation energy. Then the AB at the peak is called activated complex. As in the question, they have to show your enthalpy change. Difference between HP level and HR level is your enthalpy change. And it's positive because HP is higher than HR, signifying endothermic reaction. Going to number 6. 6AI says give 2 characteristics of homologous series. Solution, members of a given homologous series have the same general molecular formula. Number 2, members of a given homologous series have the same functional group and similar chemical properties. Then members of a given homologous series are prepared in the laboratory using similar methods. I didn't say the same method, similar methods. And also I said they are similar. I did not say the same. I said similar chemical properties. So any of these two is correct. Going to question 6AII says, write the geometric isomers of the molecule BrCH2, CH double bond, CH2Br. We'll now go to the solution. So we see the first geometric isomer drawn there. That one, this compound is called Cis. Look at the Cis. After Cis, there's hyphen. Then 1, 4, hyphen again. Dibromobutene. That's the first isomer, geometric isomer, Cis. Then the next one, we'll have, look at the difference between the two. The position of the groups. So the one is called trans 1,4-dibromobutene. So the two are geometric or stereoisomers of the compound given above. Since AII says name 3 types of ion solution, have pig ion, cast ion, and rat ion. The 3 types of ion. 6BI says calculate the mass of copper sulfate that is required to prepare 400 cm cube solution of 0.25 mole per dn cube copper sulfate. And we're giving copper 64, sulfur 32, oxygen 16. So let's go to the solution. So looking at the solution, we're looking for mass of copper sulfate. So M is unknown. The molecular mass of copper sulfate is calculated there. Using the atoms of copper, sulfur, and oxygen, we got 160. Then the volume of solution we're preparing is 500 cm cube. The concentration is 0.25 mole per dn cube. Applying the formula mass over molecular mass CV over 1000 will now make mass the subject. Mass now becomes CV times molecular mass all over 1000. Then substituting the values, concentration is 0.25, volume is 500, molecular mass is 160 over 1000. We'll now have 20.0 gram of copper sulfur required. 6BII says list 2 sources of hydrocarbons. Solution: petroleum or crude oil, coal or natural gas. Any of the above, any of the two given here is correct. 6BIII mention 2 advantages of catalytic cracking over thermal cracking. 2 advantages of catalytic cracking over thermal cracking. Solution: number 1, under catalytic cracking, it is a better controlled process due to low temperature and pressure. Then under thermal cracking, it involves high temperature and pressure and can get out of control. Number 2, under catalytic cracking, it use a higher quantity of branch chain unsaturated aromatic compounds, while under thermal, it gives lower yield of branch chain aromatic compounds and petrol of lower octane rating. (6BIV) give 1 property of elements in the same period. Solution: they have the same number of shells. Elements in the same period will have the same number of shells. That is common among elements in the same period. 6BV. What is the family name of group 2 elements? Solution: we call them the alkaline earth metals. The alkaline earth metals. That's the family name for group 2 elements. Alkaline earth metals. CCI. Write an equation for the reaction of sulfur with hot concentrated thiosulfuric acid. Solution: you can see sulfur there, solid state, plus 2 molecules of H2SO4 aqueous, concentrated H2O4, giving us 3 molecules of SO2 gaseous plus 2 molecules of steam, That's the equation between sulfur and concentrated H2SO4. CCII says write an equation for the reaction between hydrogen sulfide and sulfur 4 oxide. Hydrogen sulfide and sulfur 4 oxide. Let's go to the solution. Add the solution there. 2 molecules of hydrogen sulfide plus 1 molecule of SO2 giving us 2 molecules of steam and 3 molecules of sulfur. So 2 moles of hydrogen sulfide, 1 mole of SO2 giving us 2 moles of water and 3 moles of sulfur produced. That's the equation for the reaction. CCIII says state the I, capital I, ordinary agent in CII, III, capital II, ordinary agent in CII. CII is this equation between hydrogen sulfide and sulfur oxide. So let's go to the solution. Solution I, the ordinary agent there is SO2. Why is it SO2? Because if you go to the equation, SO2 is the solution state. Here is plus 4. And then on the product side is 0. So the ordinary state of SO2 decrease from plus 4 to 0. Because the ordinary agent is that sort of that must be reduced in the dust reaction. So that's why SO2 is an agent. The agent is hydrogen sulfide. Why? Because it was dyes. Hydrogen sulfide is in hydrogen sulfide, sulfur is -2, while at the product side, sulfur is 0. That means the state of sulfur has increased. The agent must be oxidized in the dust reaction. So the answer for I, the agent there is SO2, or the agent is hydrogen sulfide. CCIV. How many electrons are present in the following ions? I, manganese 2 ion, mass number 24, atomic number 20, atomic number 12. Then II, sulfide ion, atomic number is 16 and mass number is 32. Let's go to the solution. Going to the solution for the first one, the answer is 10 electrons. So one element is positive charge. It means deficient in electrons. Look at that magnesium 2 ion. So the number of electrons now become 12 minus 2. That plus 2 means I lost 2 electrons, giving us 10 electrons. While for sulfide ion, when element is negative charge, it means that it has excess electron. The number of electron for that negative charge means it gain electrons. So for sulfur, the electron now becomes 16 plus 2. That gives us 18 electrons for number 2. So always stay connected as we come to the final conclusion or solution to NECO 2023 chemistry examination. Remain connected. If you have come across this channel by just random search of YouTube, get subscribed to the channel so you can be seeing our videos as we continue. Thank you.